Okay, so this will be maybe a 10-minute video on derivatives of log functions. Okay, so we've had the basic shape of log done before, and it's asymptotes towards the y-axis, and then it goes up to the right-hand side. It goes through at 1, and the shape is the same. At the moment we don't have a base, but the basic shape is the same, and the base would change what it might look like exactly, but it'll always go through 1. Now you can't have negative numbers for x because there's no index that gives a negative answer. So the curve looks like that. And just so you know that these things actually have an inverse, so you've done exponentials before, and the exponential function looks like that, and these guys are the inverse of each other. So if you look at the line y equals x, they're a mirror of each other. So if this was, like for instance, if this was y equals log 2x, then this would be y equals 2 to the x. If this was y equals log ex, which we're going to be doing, then this would be y equals e to the x. So they're inverses or reciprocals of each other, and they're reflected in the line y equals x. Okay, copy that when you're ready, come past. Okay, so just to make sure what we're looking at, like for instance, if we're trying to plot y equals, say, log 10x, the reason it looks like this is, so if we're plotting for y equals 3, like we're plotting y equals log 10x, so this is the y value. When you do the substitution, the x value is 1,000. Now I haven't done it to scale, but you can see that 1,000 would be way out here. So the line goes slowly up, and it will keep going up to infinity, but it just goes really slowly. So for instance, if the answer was -3, if that was the y value, then you can see that the answer is a very, very small fraction, and it'll keep getting closer and closer, but it will never get there. Okay, so that's why the shape is as it is. Okay, so if the function can be drawn, okay, if we can draw the function, then at any points we can find a tangent. Okay, so if you can draw it, you can find a tangent. And if you can find a tangent, then the gradient of the tangent is measured by the derivative. Okay, so everything that has a shape can have a tangent, and a tangent is the derivative. And how do we get the derivatives is on the next slide. Okay, so this is the maths behind it. Okay, so the inverse is going to be y equals e to the x. Okay, and so if y equals e to the x, then the inverse is you switch the letters over, x equals e to the y. And then if I'm going to derive with respect to the letter y, so dx dy is the derivative of e to the y, and the derivative of e to the y is just e to the y. Now at the end of the day, you don't have to understand the proof, but you have to see the proof. Now, the derivative is not normally dx dy, the derivative is normally dy dx. So if dx dy is e to the y, then if I turn these guys upside down, then I have to turn this upside down, and I get 1 over e to the y. But e to the y is the same as x. So the upshot is, and this is all you have to remember, if you have log ex, then the derivative is 1 on x. Now, there are obviously other functions, you know, whatever, and I might do a separate video, but at this stage, the only derivatives we have to worry about are log e's. Okay, so there are other rules for other functions, but for our purposes, we'll just do log e for the time being. So let's have a look at the next slide. You don't have to worry about the proof, okay? You don't have to worry about that. It's just I have to show it to you. Okay, so in summary, if you have y equals log ex, the derivative is just 1 on x, but you don't always just get a simple x, you get a function of x, and the shortcut is the derivative of log e fx is f dash x over fx. So you put the derivative of the function, and you put it on top of the function. Okay, and we'll have a look at some examples on the next page to see how easy it is to use. Okay, so our first derivative is y equals log, okay, so e, I forgot to put the e's in. So we've got log e 2x, so the derivative of 2x is 2, and then whatever the function is you put on the bottom, and then you just cancel down. Okay, so in actual fact, log e x leads to 1 on x, log e 3x also leads to 1 on x. Okay, so that one's a really simple one. Next one. Okay, so the derivative of x squared plus 2x is 2x plus 2, and then whatever the function is, you put it on the bottom. In this particular case, even if you factorize the top, you get 2 over x plus 1, and you get x plus 2. Nothing cancels out, so the first answer in black is okay, and the answer factorized is okay. Okay, so copy those down and come across. Okay, so now we're going to use the derivative to find gradients, and we'll also find the equation of a tangent. So we're going to use these things. Okay, so first thing you do is, so we've got y equals log e x squared. So y dash equals 2x over x squared. The derivative of x squared is 2x. And then the x cancel out, so you end up with 1 on x again. So at x equals 2, y dash equals 1 over 2. And that's the end of it. Okay. Next one. Y dash will be equal to 5 over 5x, which again is 1 over x. At x equals 1, y dash equals 1 over 1. And eventually we have to sub it into y. We've got to have a y equals mx plus b answer. So we've got the derivative, we've got the x, so we need the y. So at x equals 1, y equals log e 5 times 1, which is log e 5, and just leave it like that. So then we do y equals mx plus b, log e 5 equals x, m is 1, x is 1 plus b, so b equals log e 5 minus 1, and so the equation of the tangent is y equals mx, so 1x plus log e 5 minus 1, so the answer is just x. Okay, and that's your answer. Okay, let's move on. Got 2 slides to go. Okay, so let's see some harder ones. Okay, so first of all, you've got to remember that that's the same as 3x minus 1 to the power of half. So the derivative is the derivative of the bracket, which is a half. 3x minus 1, subtract 1 from the power, multiply by the derivative of the bracket, and then divide by the function, which is 3x minus 1 to the half. And we've got to do some tidying up. Okay, so what we do is this bracket here will come to the bottom because it's got a negative power. The 3 will stay on and the half will come down. So the answer will be 3 over 2 3x minus 1 to the power of 1, because this minus a half and this half, when you put them together, will make a whole on the bottom, and that's the answer. Okay, so the next one. So y dash equals, so the derivative of that is multiply by the power, leave the bracket, subtract 1 from the power, multiply by the derivative of the bracket, divided by the function x squared minus 1 cubed. Okay, so then what we can cancel out. Okay, so we've got that kills 2 of them and leaves 1 behind, and that's it. 3 times 2x is 6x over x squared minus 1 to the power of 1, which is the same. So that's just 6x over x squared minus 1. Okay, so copy that when you're ready to come across. Okay, so there's some exercises to do, and I've actually, if you need extra practice, there's another worksheet. Extra practice. There's a worksheet also on Moodle. Okay, and that's it. Okay, thanks. See you next time.